My dear students, I welcome all of you for today's session. I need to say in this semester, I have been assigned a subject, design and analysis of algorithms. Now, in today's session, I'm going to give you an introduction to this subject, design and analysis of algorithms. So, before 1 hour, we are going to start off with a new subject. Okay, whatever it may be. I mean to say, in first semester, I started with C programming language, right? Uh, Similarly, in previous semester, I started with the discrete mathematical structures. In the same way, whenever we are going to start with any new subject, okay, we need to know why we need to learn this subject. I mean, why we need to study this subject. What is the use of this subject? Okay, and what are the applications of this subject? So now I need to tell you why you need to study design and analysis of algorithms. Okay, first let me tell you, this is the foundation subject for a computer science students. Okay, I mean to say, before you're going to start with any other subject in your computer science stream, you need to be familiarized with design and analysis of algorithms. Let me give you an example. Suppose you are going to construct an house. Let me tell you, you're going to build up an house. Okay, so first and foremost thing, what you are going to do, you're going to do the foundation. You're going to build a foundation, right? So once the foundation is strong, then you're going to proceed with the subsequent floors, ground floor, +1, +2, so and so. Means always when we construct a house, we are going to start with a strong foundation. Similarly, for you being a computer science student, okay, you need to, your foundation should be strong. Foundation in a sense, design and analytical skills should be strong. Okay, so whenever you're given some problem, okay, how you're going to analyze that problem and how you're going to develop a solution, okay, and you're going to design a solution for that problem. This is the foundation. Okay, so let me tell you, this subject is the foundation for your computer science. Okay, I mean, it's a found. I said it's a foundation. Okay, so first you need to be strong with algorithm, then you can proceed with all other subjects in computer science. Because in all other subjects, you're going to make use of applications of algorithm. Okay. So now, coming to the contents of this session, these are the contents of today's session. The first, I'll discuss with an objective. Okay. And then, finally, once you are completing this course, what are the learning outcomes? Okay, we'll see that. Okay, next, we'll have to look at textbook prescribed by VTU. Okay, so next, we'll have an introduction to algorithm. Then we'll see what is notion of an algorithm. Got it? Next, I'll demonstrate you what is an algorithm. Okay, with an example. Okay, so now let me look at the objective. Okay, so see, in the first and foremost objective is that you will start with a recursive problem. Okay, and this subject we are going to start with a recursive problem in the next session. Okay, that's the first problem. So recursive means I think you have learned in CCP. What is recursive? Repeat a function invoking a problem invoking itself. We call a recursive. Got it? Uh, the first and foremost, the first objective is that you will come to know about recursive. Got it? Recurrence relation. Next, we'll look at something how to, suppose we have designed any problem, okay, so solution for any problem, how to analyze efficiency, okay? I mean, how efficient is that algorithm, how much time it's going to consume, how much space it is going to consume, we'll see those. Next, suppose, let me say you will be given a problem, okay? And for that problem, each individual may come up with their own solution. Okay, that solution is based on different ideas. Okay, different strategies. For the same problem, each will come with their own solution, and all the solutions will be based on different ideas. Okay, so similarly in here we are going to have a look at those strategies for the same problem. Okay, some strategies, some of the strategies what we see, we are going to discuss what we call something greedy strategy, divide and conquer techniques, dynamic programming, Max Bloom-Minkert theory for design algorithms, and some other. Okay, like some other we say branch and bound. Got it? We will see all those design strategies. Also, we'll have a look at some popular graph algorithms, okay, randomized algorithms, and computational complexities. Okay, some problems. Okay, let me tell you. Square root. Okay, for example, square root may not give an exact solution. Solution might be approximate. Got it? Some cases. Okay, that we call approximation algorithms. We are going to discuss what type of design strategy for a problem with approximate solutions. Okay, and some randomized algorithms. Okay, I mean to say randomized algorithms, I need to generate some random inputs to analyze the efficiency of any algorithm. So we'll have a discuss about those randomized algorithms. So finally, what you'll learn how to design efficient algorithms for any problem. Okay, let me tell you. So you have heard about sorting problem. For sorting problem, I think you have come across bubble sort, selection sort, right? So similarly, we have something as quick sort, merge sort, heap sort. So all these problems, all these solutions for the same problem, that is sorting. But how we are going to differentiate the solution, that is with respect to efficiency. Got it? So we'll see how to design an efficient algorithm for a given problem. So learning outcome. Okay, what is the outcome of this subject is that I said, I look at the first point, get a solid foundation in algorithm design and analysis. I said, this is a foundation, right? So you're going to get a strong foundation skill. So I mean to say, whenever you're going to whenever you're given a problem, you will think of that problem, you will analyze that problem, and you will come with a solution. Got it? You will think and you will come up with a solution. So now once you have designed a solution, each individual might have designed a solution, okay? But how to differentiate whose solutions are better or the best, okay? So we need to look whose algorithms runs very faster, whose algorithm is going to consume less time, got it? So that we need to analyze. As we'll see perform how to analyze the performance of algorithm. So next, let me say, next outcome is that you might have designed a solution, okay? And your solution might work for almost all instances, all inputs, but it may fail to give a result for one of the inputs. So in that case, you are going to call an algorithm as incorrect. I mean to say, you might have designed a solution, that solution works almost 99%, 99.9%, but might have failed for 0.01%. So what is the reason for that? Okay, we need to look, and we need an algorithm which works 100% perfect, correct. Okay, then we'll look at the major algorithms and data structures, and finally we'll come up with the design paradigms and method of analysis. Now, coming to textbooks, okay. Coming to textbooks, VT has prescribed two textbooks for you. One is the Introduction to Design and Analysis of Algorithms by Anani Levitin. And the second is Computer Algorithms C++ by Sarta Sahni Rajasekaran. Got it? And apart from this, you can refer to reference books. One is Introduction to Algorithm by Thomas H. Corman and two more authors. And also you can refer to Design and Analysis of Algorithm by S. Sridhar. Now, what is an algorithm? Okay, now let me tell you, it's very important. Now that your subject starts here, we have just had a discussion about objectives, outcomes, and textbooks, right? Now we'll see what is an algorithm. An algorithm is a finite set of instructions that, if followed, accomplishes a particular task. I mean to say, see, you might you have written a C program to check a number is a prime or a not, right? So I mean that what the program you have written is nothing but sequence of instructions. When I given on input, okay, one number to check whether it's a prime or not. So what you will do, you will try to divide that number by all number less than that. In any case, if you find that a number is going to be divisible, you're going to conclude it is not prime. If it is not going to be divided by any of the number less than that, you're going to conclude it's a prime. Got it? So, means sequence of instructions. Okay, algorithm, I mean to say, it's a sequence of instructions that I need to follow to achieve some task. Some goal has been defined. Okay, to accomplish that goal, what are sequence of instructions that I need to follow for a given instance? That is an algorithm. Got it? I repeat, an algorithm is a finite set of instructions that, if followed, accomplishes a particular task. In addition, all algorithms must satisfy the following criteria. Okay, so I mean to say, let me say, I have some problem. Okay, for my problem, for example, when I say the problem is to compute the square of any number, there's for this problem you're going to write a C program with that takes one input. Clear? And means if you are given any input, it's going to give the square of that number. Means, and similarly for algorithm is nothing but a solution for some problem I said, right? So in that for that particular problem, there might be an input, and need not for all problem. Okay, need not for all the algorithms. There should be an input. For example, let me say daily you need to let me say like temperature sense. Some sensors will be there. Okay, we are not going to give any input. Okay, on sense. Okay, like let me say temperature sensor. Okay, temperature we are not going to give an input. Just if temperature exceeds some threshold, it should pop up some message. Automatically, temperature sensor monitors the temperature. I mean, we are not going to give input. When our threshold exceeds, it is going to give some output. Got it? I mean to say here, algorithms, okay, can have a zero or more input. And what about output? I said at least one output, one quantity should be produced. Means when I'm going to design, when I'm going to design some solution for some problem, means I'm expecting some output, right? So without expecting any output, what is the need of algorithm? So I mean, we are designed a solution. We are expecting some output. I mean, so you need to know that. You need to remember, input is an option. Input may be given or may not be given, but always there is at least one output. Okay. Next, definiteness. I mean, each instruction should be clear and unambiguous. I mean to say, we have written some instruction. Okay, that instruction should be very clear. Means there should not be ambiguity. The instruction should state clearly what it is going to do. Got it? So that is definiteness. Yeah. I mean, there should not be ambiguity. The processor, my instruction should not make processor to be ambiguous. I mean, processor should not get confused. What should be done or what should not be done. Okay, that is definite. So finiteness. So finiteness means here I have designed a solution. Okay, my solution means you have seen when you run your program, it runs for your minute and it is going to end, right? And finally is going to give a solution. So finiteness means my algorithm should always end. Okay, your algorithm should not enter an infinite loop. Okay, of course there are some infinite algorithms, but I'm not. We are not dealing here. Finiteness means my algorithm. Okay, after executing for some finite amount of time, it should produce an output. Got it? So this is finiteness. Okay. So next point, effectiveness. Every instruction must be very basic so that it can be carried out even by hand using only pencil and paper. I mean, effectiveness here means we are, in general, I need to say algorithm is not a machine dependent. Okay. It's an independent of machine or it's an independent of any programming language. Got it? So I mean to say, because in the mathematics you'll be taught how to solve right by hand, right? We're going to perform step by step. So even that I'm going to give, I will call it as an algorithm. Got it? So means effectiveness means every instruction should be very basic. Clear? Uh, so these are some points. And let me recapture. So what is an algorithm? It's a finite set of instructions that accomplishes some task. Okay, and what are the criteria associated for input? Input means there might be zero or more input. Output, at least one output should be produced. Definiteness, each instruction is very clear and unambiguous. Finiteness, okay, I said the algorithm should terminate after some time producing an output. Effectiveness, each and every instruction should be very basic that can even be carried out by pencil and book. No, no, let me look at notion of algorithm and problem. Okay, what is an algorithm? I said in other terms. Okay, for the same all those five steps club in this definition. Okay, an algorithm is a sequence. Sequence I said finite. Sequence of unambiguous instruction. That is unambiguous means definiteness. For solving a problem, that is for obtaining a required output for any legitimate input in a finite amount of time. Here I mean this legitimateness. For example, your problem is to find the square of an number. Okay, so problem is algorithm is to find the square of a number. So what is an input for this? A number. It can be negative number. It can be positive number. It can be real or an integer. But can you find a square for an alphabet? Got it. So the algorithm would have been designed and the input need to be stated. What should be the type of input? Clear? So that input for all valid input, my algorithm should work. Got it? So algorithm is a sequence of unambiguous instructions for solving a problem, for obtaining a required output for any legitimate input in a finite amount of time. So now I said the algorithm is not machine dependent. Got it? So when algorithm comes, okay, first you will be given some problem. Okay, so first thing what you need to do, you need to analyze the problem. What actually that problem is like. Okay, once you go, you need to read through the problem statement. You need to analyze it. Once you analyze the problem, then you will think of how to solve the problem, right? How to give a solution for that problem means in your mind you're going to think clear, and that thinking how to solve in your mind you come up with the solution, and now that solution you need to present to an audience, right? So presenting the solution for the problem given is nothing but an algorithm. Got it? Clear with this? First, you are given a problem. You will read through the problem statement. You will then analyze it. Okay, and you will think how to solve the problem. Later, once you come up with a solution in your mind, now you need to present that to an audience. That is in the form of an algorithm. Okay. Next, once algorithm is you can it can be there are three ways of representing an algorithm. Presenting my solution that I'll discuss in next session. And let me tell you now what are them. They are nothing but flowchart. They are nothing but natural language form and pseudocode. We will see that. So now, since we are computer science professional, we will always represent my algorithm that computer can understand. Got it? So, I mean, you can write in the form of pictorial on a weapon using pencil and paper. Okay, even that's an algorithm. But now in this case, I am representing in a computer understandable form. So now I designed my algorithm, right? So next, my algorithm, I said it's a machine independent, but now I need to translate it into machine understandable form using any programming language. Now, on giving an input, my computer processor runs on that, executes, takes that input, and gives a corresponding output. So let me take an example. Okay, problem. One problem I was saying. Let me tell you. Given a problem, sorting. Got it. So sorting means what you will think, or you in your sorting problem is that you will come to know you'll be given a sequence of some n numbers, and real numbers might be given, and integer numbers might be given, or n strings might be given, and alphabets might be given, any number. Okay, now let me be specific. I give a sequence of n numbers. Let me call A1 to A10. So what is an objective of this problem? I need to sort out. I need to reorder. This is an objective. Got it? So now you will think, oh, I can sort. Okay. So given and you will once you go through the numbers, you will know which number will come first, which number will come second, and which number will come last. So, but I need to make my machine to understand, my machine to perform the solution, right? Yeah. So in this subject, you're going to learn that we will come across variety of algorithms to which you can make your machine to understand. Okay. Mm, and that's algorithms. For example, at the end of the subject, you'll come to know if sorting is a problem you have given in any case, or you will think of the sorting algorithms you have learned. There are selection sort, insertion sort, merge sort, and many other. There are heap sort, quick sort, and so. Got it. So now you have the solution. Yeah. The solution, what I said, it's in your mind, right? But you need to represent. You need to present to an audience, and the presenting to an audience we call in the form of an algorithm. Okay. I said that there are three methods: flowchart, natural language form, and pseudocode. Pseudocode is often used to work. Okay. So see here. Selection. Let me take here one solution, that selection sort. Got it. So selection sort for this, once you have become familiar with that, in your mind you have that. So you know input is nothing but we call an array of n numbers, and output is what? Sorted in increasing order. So algorithm selection sort what actually sorting solution here I have shown that for I equals 1 to n, swap a of I with smallest of ai through a of n. I mean to say, to find the first element in the list, you are given n elements. In those n elements, you need to identify which is the least one. Among n, you identify the first list, and that is the first element, right? You swap that element with the first element. So first least element, now it's in first position. Got it. So next what we'll do, we need to determine second least element from the remaining n minus 1 numbers. And we need to swap that second least element to the second number. Similarly, we need to find the third least from the third to last number, and we need to swap with the third index. And this is our selection. Okay, so this is about today's session. Got it. So I repeat, in this session, okay, what are things we have discussed? One is an objective. So objective, I said, we'll start with recursive algorithm. We'll see in next session. Okay, and we are starting with recursive algorithm, and discussed. I said there are many strategies. When a problem is given to an individual, we will have his own strategy, right? How to solve it. Got it. So the strategy will follow some rhythm. Got it. Some paradigm. We call them as a divide and conquer. We call brute force, decrease and conquer, dynamic programming, branch and bond, so and so. These strategies we are going to discuss. Okay, and we have some problems whose solutions will always be approximate rather than exact. For those, we are going to discuss approximate algorithms, and we are going to discuss random algorithms. Finally, our objective is that you will come with an analytical skill, efficient way of designing a solution for a network. Okay. And then just we had an introduction to what is an algorithm. I said algorithm is a finite sequence of unambiguous instructions. Okay. Finite sequence of unambiguous instructions. One followed accomplishes some task. There are 5 points. One is input may be or may not be, but output should be there. Clear? And definiteness, there should not be ambiguity. Finiteness, it should terminate and it should be effective. I said it should be very basic. Got it? So, and also we have discussed one example, that is selection sort. So with this, I'm winding up the current session. And next session, we'll start up with the algorithm specification, the pseudocode representation, okay, and different other methods of representing an algorithm. Yeah, thank you for listening.